ఇంకా ఏది పెన్ లేదు ఇక్కడ తెలుసు ఈ పెన్ ఇక్కడ ఉందా? Okay, good afternoon students. I am Srinivasan, physics lecturer from Spark Academy. Today we are going to discuss selected short questions from second year physics, inter-secondary physics or senior inter physics. Again selected long questions also, because being today February 28th, so we will be busy in preparation from tomorrow onwards, March 1st, because language will be there, other subjects will be there. So March 5th first year, March 6th second year exam starting with second language. So I'm sorry, we will not be able to complete all the blueprint. According to blueprint, there are some 20 to 22 questions are there, short questions actually. In that maximum extent I will try at least 15 questions. We will discuss short questions, friends. Remaining I will just tell you whichever are very important, difficult, I will discuss short questions second year. Thereafter long questions, there are about 8 long questions are there. Waves only 4 questions are there, out of that 2 or 3 I will discuss. Electricity 2, nuclear physics 2, 4 to 6 questions, long questions we will discuss. Okay students, then today now first we start with short questions. We already discussed very short questions on Monday we discussed all very short questions. All very short questions we discussed. Now we are doing discuss short questions starting from ray optics. Starting from short questions. Sir, color. Sir, Nitin sir, color हो sir, color blue or black color ఇక్కడ okay. Short questions, inter second year physics, inter second year physics. So there are certain chapters in which according to blueprint we are asking from that chapters only short questions. So ray optics, first we are starting with ray optics. Starting from ray optics. So first, very important, number of times they asked what is the question. Define critical angle, explain total internal reflection, total internal reflection with a NEET diagram. So this is the question, very important question. So here first we are discussing about critical angle and we will draw diagram for that. Critical angle definition: if the light ray travels from optically denser medium to, you can write denser medium, but optically denser means where speed is less, speed of light is less. Optically denser medium to optically rarer medium. This is very important sentence. optically denser medium to optically rarer medium. The angle of incidence, the angle of incidence for which angle of refraction, for which angle of refraction is 90 degrees or greater surface of separation. Angle of refraction should be 90. Known as critical angle, is known as critical angle. Critical angle. So main important point is when light ray travels from denser medium to rarer medium, optically rarer medium, the angle of incidence for which angle of refraction is 90 degrees is known as critical angle. And one of the angle of refraction would be 90. So now I am keeping diagram for this next page. I am keeping diagram. How to keep diagram for critical angle? Critical angle directly you can keep, or what is the stage of critical angle? Okay. So this is normal. This is normal. Normal. This is denser. Like let us say glass. Denser like glass. Here air. This is called optically rarer. Denser rarer. For example, I am drawing full diagram. Let us say angle of incidence is less than critical angle. The ray will come out. This is I less than C. I less than C. Okay, students. I less than C. Now again I am drawing normal. This is normal. If I keep increase angle now, this is the angle. This angle is nothing but equal to critical angle. The ray will graze, then angle of refraction will be 90 degrees. This is known as critical angle. I is equal to critical angle theta C, or I is equal to C. The corresponding angle in denser medium is known as, here I is less than C, angle of refraction is there, less than 90. This is less than 90. Less than 90, but it is equal to 90. This is called critical angle. This is called critical angle. Okay. So what is the relation between refractive index and critical angle? I am drawing. Relation between refractive index. Let us say refractive index, absolute refractive index of this is glass. Here we can take 1. Relation between refractive index and critical angle. I am writing Ri as refractive index and critical angle. If you can write relation is better, otherwise also they will give marks. Relation between critical angle. By Snell's law, n is equal to 1 by sin c. One angle is 90 degrees. Refractive index n or mu is equal to 1 by sin c. Refractive index is inversely proportional to critical angle. More the refractive index, less the critical angle. This is the diagram for critical angle. Now total internal reflection, I am explaining. Next concept, what is there in the 4 marks, this is 2 marks question. Next, total internal reflection. Total internal reflection. Total internal reflection. Students, total internal is also called TIR. TIR means total internal reflection. TIR. TIR, total internal reflection. So here conditions are what? For total internal reflection, conditions are light ray should travel from denser medium, optically denser medium to rarer medium, or optically denser medium to rarer medium. Denser medium to rarer medium. This is the condition. Conditions for total internal reflection. Second condition, angle of incidence is greater than critical angle. I greater than C. I greater than C. What is C? Critical angle. Angle of incidence I greater than C, where C is critical angle. Where C is critical angle. Then what will happen? Then light ray, it won't undergo refraction. The light ray reflect back to same denser medium, same denser medium, same denser medium. There is no refraction now. Light ray when angle of incidence is greater than critical angle. Please remember, light ray should travel from denser medium to rarer medium. Angle of incidence is greater than critical angle. Light ray reflects back to same denser medium. This is called total internal reflection. This is known as total internal reflection. So diagram, I am drawing diagram in the next page. Next page, I am drawing diagram. TAR diagram is, you can draw like this. So angle of incidence, let us say greater than critical angle. The ray will reflect back to same. This angle and this angle will be equal. Angle of incidence is equal to angle of reflection. This angle of incidence is greater than critical angle. This incident ray, this is reflected ray. This is called total reflected ray. Total reflected ray. Total reflected ray. Angle of incidence is greater than critical angle. For example, critical angle is 40, you have to keep 42 or 43 for glass, something like that, 45. So this is normal. This is normal. This is denser. This is rarer. This is denser, rarer. So diagrams are compulsory. If you keep diagrams, it will be very good. So you get full marks. This is the concept of critical angle and total internal reflection. Often this is coming for the examination ray optics. Next thing is explain the formation of mirage. This is theoretical. Explain the formation of mirage. Explain the formation of mirage. Friends, explain the formation of mirage. Mirage is the application of total internal reflection. My dear students, mirage is answer. Mirage is application of total internal reflection. Application of total internal reflection. Application of total internal reflection. First you have to write this sentence. Mirage is the application of total internal reflection. So where you will observe this generally? In deserts. In deserts you will observe in hot days. So you will give general example. In deserts what will happen? Sand gets heated first. Because in summer, deserts 46, 47 temperature will be there. So sand gets heated, air near to the sand gets heated up and rises. But above layers are cold layers only. Cold air refractive index is more and hot air refractive index is less. Whenever light ray travels from sunlight travels from cold air to hot air, there is a possibility when the angle exceeds critical angle, total internal reflection takes place. Due to this, what will happen is very distant person can see on the sand a pool of water. That is illusion, due to illusion. So any tree is there on the ground, in the pool of water, it is like acting like a mirror. You will see the image of that, inverted image of that. So I will draw the diagram also. I will try to draw a rough diagram for that. First, what is the concept here? First concept. In deserts, in summer, air near to the sand gets heated and rises. But above layers are cold air layers. Okay, in deserts, in summer, air near to sand gets heated and rises, but above layers are cold air. Second point, refractive index. RI means, you write full form, but I am writing short form here. RI means refractive index. cold air is greater than refractive index of hot air. Okay, students. So next points I'm writing in the next page. Third point. What is third point? When light from sunlight, light ray from sun travels from cold air to hot air, at the boundary of cold air and at boundary, if angle of incidence is greater than critical angle, the ray will reflect back. The ray will reflect back. Reflect back to cold air, reflect back to cold air by total internal reflection. Total internal reflection. Okay, so last point. For a distant observer, it appears like a pool of water or shining surface on sand due to total internal reflection. TIR means, students, you are writing in examination, don't write abbreviations. Refractive index also, don't write RI. Refractive index only full you write in examination. But now you are hearing my lesson. TIR means total internal reflection. RI means refractive index. So this is happening. So like a pool of water from distant object. But as he comes nearer, that reflected ray cannot enter into your eye. There is a camel, one person is traveling. From distance it appears there is a pool of water. He wants to drink the water, he comes nearer, but there is no pool of water. This is an illusion. This is happening due to total internal reflection. Just like a mirror, it is appearing. So that's what he will keep in book, diagram of tree. So whenever the last ray coming from the tree, so the tree illuminated by sunlight enters into the person, so direct reflected enters, you will see inverted image of the tree. So that diagram, if you can make it, you can make it definitely from the books. And these are two important questions I discussed in ray optics. Diagram, I think students, diagram you can manage from the Mirage textbook. Diagram, tree, inverted image of the tree and diagram, anything is there, you can see to it. So now there is important question like rainbow and all that, but it is appearing very rare in Telangana examinations. Maybe AP examination rainbow is asked. When you are appearing in Telangana, rainbow is a dispersion. Due to dispersion, refraction, dispersion and total internal reflection. You are going to get primary rainbow and second rainbow when water droplets are formed during rainy season. The sunlight falls, it splits into colors. So rainbow, please go through it. Time permits, lastly I'll explain. And then simple microscope also. In Telangana examination, it is very long back, 15, 16 examination they asked. Recently you see only exam 19, 20, 23, 24. 19, 20, 23, 24 you see first. And 21, 22 are Corona years questions. Please see to it. So I am going to the next chapter, wave optics. Next chapter called wave optics. Simple microscope, if you want me to explain, lastly I'll explain simple microscope also. Lastly, time after discussing long questions, Today we want to close because it's February 28th, last day of February. Better to complete. So today, so you see the model how we are teaching this. Now wave optics. In wave optics, most important question first definitely appears. What is the wave optics? First question is explain Doppler effect in light. You see, you can take my notes also. You get full marks. Explain Doppler effect in light. Explain Doppler effect in light. Distinguish between red shift and blue shift. Distinguish between between red shift and blue shift. Red shift and blue shift and blue shift. Red shift and blue shift. Doppler effect. Doppler effect in light. So you know in sound also you know Doppler effect, that will do long question students today. Doppler effect. Okay, so here definition I am writing. Answer. Definition. What is Doppler effect in light? What is Doppler effect actually? The apparent change in the wavelength or frequency. Generally in sound you will write only frequency. Here you are writing wavelength also. Apparent change in the wavelength or frequency of light whenever source of light is moving away from observer or moving towards observer. Moving away from observer, where observer is there? On the ground. Observer is there on the ground at rest. Observer is on the ground at rest. Only source is moving. What is source? Star. Source is nothing but star. So here answer, definition. First I am writing definition. Definition I am writing the apparent change. The apparent change in wavelength. Apparent change in wavelength or frequency. Brackets you write. Apparent change in wavelength or frequency of light when source of light is moving away or towards observer at rest or stationary observer on the ground. Observer at rest on the ground. So what is the definition? Apparent change in the wavelength of light when source of light is moving away or towards observer. Change in wavelength or change in frequency. Wavelength increases, frequency decreases. Wavelength decreases, frequency increases. So this is what happening. So this is the definition of Doppler effect. I am taking next page, red shift. What is meant by red shift? Red shift means what? Red color is having maximum wavelength. In WebJar, violet, indigo, blue, green, yellow, orange, red. In that red is having more wavelength. So red shift means what? When star is moving away from us, us means observers, moving away from observer, wavelength increases. That means frequency decreases. You need not write both. Whenever star is moving away from the observer, wavelength increases. And color of the star changes to red by wavelength increasing from normal wavelength to red wavelength. This is called red shift. Redshift means what? When the star is moving away from us, when the redshift will come. When the star is moving away from the observer, wavelength increases, color of the star changes to red. This is called redshift. You can write the formula. Lastly, I'll write the formula. I'm writing blue shift also. I'm writing, why I am not writing yellow shift? So why not writing violet shift? Violet is not very much visible for eye sensitive, because that's why in violet indigo is leaving that and blue is telling. Blue shift. Blue, what is blue shift? When the star is moving towards us, star is moving towards observer, moving towards observer, wavelength decreases, color of star changes to blue, blue color. This is called blue shift. This is called blue shift. Okay, student, these are definitions. I am writing the formula also here, delta lambda by lambda. If you want to write formula, you can write delta lambda is equal to plus or minus V by C. Delta lambda by lambda is equal to plus or minus, what is V? Velocity of star, 1 kilometer per second or 0.5 kilometers per second, velocity of the star. C, velocity of light. That you know, 3 × 10⁸ meters per second. Delta lambda, shift in wavelength. Lambda, initial wavelength. Lambda, if you want to write formula, you can write, otherwise you can leave it. It is better if you write mathematically initial wavelength. Here, when plus will come, red shift means plus will come. Blue shift means minus will come. Whenever you are changing delta lambda by lambda, red shift means plus will come. Blue shift means wavelength decreases, that's why delta lambda will be negative, that's why minus sign will come. So this is the explanation of red shift and blue shift. Then I am explaining, this problem. ఇది అడ్డం పడితే పడిపోతానేమో, ఇది ఒకసారి ఉండండి, దానికి రావాలి, అటుపక్క పెట్టుకోవాలి. ఇది ఇది ఎక్కడ పెడతారు చెప్పండి, మళ్ళీ వచ్చేస్తుంది. Okay, this is regarding red shift and blue shift. Then we are telling about how do you determine the resolving power of your eye. They are asking this question, how do you determine resolving power of your eye. Resolving power of your eye. A normal eye, normally not like old person like that, but how do you determine the resolving power of your eye? What is meant by resolving power? The eye is able to distinguish two closely spaced objects very clearly, that is known as resolving power. Resolving power means the ability of the eye to see two closely spaced objects is called resolving power. So he will find out resolving power by an experiment, by small experiment he is doing. With that experiment he is able to find out resolving power of eye, students. So here what is the definition first? Definition of resolving power. Resolving power of eye. The ability of eye to see closely closely spaced two objects clearly is known as resolving power. Resolving power for eye will be there, telescope will be there, microscope will be there. The ability of eye to see closely spaced two objects clearly is known as resolving power. So if you see your eye is okay, you can see, but resolving power is very less. You can see two closely objects as single object only you will see. So what is the resolving power? How to estimate this one? So this is verified by small experiment. This is verified by small experiment. This is verified by small experiment. What is that experiment? We are showing the next page. I am showing the experiment. What is the experiment? Is on the wall is pasting some diagram showing the black strips. So this is one object. I am keeping very closely another black strip. Spacing is less. One more black strip is there. This is black strip. In between that white strip is there. This is called white strip. So here spacing is very, very less. Now I am next spacing, I am giving you little bit more. Next I am drawing like this. Black strip width is same only. Okay, students. Then if you go left to right, what I am doing is slowly I am increasing the space now. Black strips. White space is increasing. Then a little bit increasing more here, like this. This I am pasting on the ball. Yeah, I mean, I point again. That. Diagram going there. Again I am drawing diagram. Black strip, roughly I will draw. Again one more thing, very closely you are keeping. Like this. Little spacing you are increasing. Like this. Little bit spacing you are increasing. Like this. Still spacing is increased. ఏంటంటే రాయము ఆయన రమ్మనండి, ఆయన ఎక్కడ పోయాడు? తీసేస్తున్నాడు. Okay. So here the above diagram consists of black strips. And that what is black strips? Black strips of equal width. Black strips of equal width. Of course here blue color is there. Equal width. Two black strips are separated by a white strip of increasing width from left to right, from left to right. Here black strip's width is remaining same, white strip width is increasing from left to right. This is the above diagram is pasted on wall. The above diagram is pasted on wall. By moving I closer or farther from wall, by moving closer or farther from the wall, pattern is observed. For the person right side, the right side black strips appear separate because their separation is more. Here they appear as one only. Here left side appear as one. From left to right, if you are moving closer or farther from left to right, you move. For the person right side, for the person right side, black strips appear clearly, appear as separate, clearly. This is the experiment you are doing to find resolving power. Left side strips merge into one, but we are moving from left to right. You are moving from closer to the wall and away from the wall and left to right. If you observe the pattern, what will happen is right side strips are clearly visible, black strips, than left side strips. This is how you are finding resolving power of I. Resolving power of I is given by small d by capital D. What is d, small d? Distance between black strips. Capital D, distance of the pattern from wall. Distance of pattern from wall. Distance between black strips means that is white strip width. What is distance between black strips means? That is white strip width. That is formula. So this is how you are finding resolving power of your eye. This is the two important questions from wave optics. Repeatedly they are asking. Dr. Effort is asked number of times, TS 19, 19, 22, 23 also. Resolving power is also asked 18 and 24, TS 18 and 24. Thereafter, wave optics, one more question is there. Principle of conservation of energy. Principle of conservation of energy is valid in case of interference as well as diffraction. What is interference? You are getting bright fringe, dark fringe separately. Bright fringe, dark fringe separately. Maximum intensity, minimum intensity separately. So maximum intensity means, minimum intensity means darkness. But here what will happen, wherever intensity is more and wherever intensity is less. But here redistribution of energy takes place and law of conservation of energy is valid. Somewhere energy is lost, somewhere energy is gained. So total energy remains constant. That is theoretically you can read, student, state principle of conservation of energy in case of interference as well as diffraction. So I am going to now next chapter, electric charges and fields. This is having more questions. Electric charges and fields. Sir, pen sir, I don't know. Pen etla. This is pen blue one. Double. Yes. Thought I pen color change here. I am trying ఆయన వెళ్ళిపోయాడా ఏంటి ఇంటికి కలర్ electric charges and fields పర్లేదండి. చార్జెస్ అండ్ ఫీల్డ్స్, ఎలక్ట్రిక్ చార్జెస్ and fields, electric charges and fields. So next chapter, in this I am mainly explaining first derive the expression for couple acting on the electric dipole. Derive an expression for couple or torque, couple or torque acting on dipole, acting on electric dipole placed at an angle theta in uniform electric field, in uniform electric field, in uniform electric field. This is asked a number of times. This is asked a number of times. First I will draw diagram. First I will draw diagram for this. I am drawing uniform electric field. This is called uniform electric field. This is called uniform electric field. Called uniform electric field. Here taking a dipole here. Positive charge and negative charge. This is electric field. This is electric field. This is positive charge. This is negative charge. So this is AB. Is the dipole, short dipole. Dipole length is 2a. It is kept at an angle theta. Now A will experience a force. Charge Q, here charge, here charge minus Q, here charge plus Q. So this will experience a force QE like this. This will experience a force QE opposite direction of electric field. There are two forces. There are two forces. How they are acting horizontally. So a dipole, see a dipole, AB is a dipole of length 2a. AB is an electric dipole. AB is an electric dipole of length 2a. Kept in the uniform electric field, uniform electric field E at an angle theta, at an angle theta. AB is an electric dipole kept at an angle theta in the uniform electric field. Okay, now so there are two forces. Dipole means what? Two equal and opposite charges. Two equal and opposite charges separated by a distance is called dipole. Two equal and opposite charges separated by distance 2a is called dipole. Plus charge will experience force in the direction of electric field. Minus charge will experience the direction force in the force opposite the electric field. Net force is 0, but one of the forces help you to rotate the dipole. What is the perpendicular distance? I am drawing perpendicular distance. This is my perpendicular distance. So I am writing a derivation in the next one. So you find couple. So I am writing in the next page. So here force experienced by each charge. Force experienced by each charge. F is nothing but equal to Q into E. That is the formula. Force experienced by each charge. Let perpendicular distance from diagram. I'll go to back side and let perpendicular distance. Perpendicular distance between what? Two forces is AD from diagram. I am going to previous diagram and showing you. So AD is the perpendicular distance. AD is the perpendicular. From ABD triangle, ADB triangle, sin theta is equal to AD by AB. What is AB? 2A. So from diagram, perpendicular is AD. Triangle ABD, triangle ADB, if you take sin theta is nothing but AD by AB. AD is called perpendicular distance. Okay, AD is nothing but AB sin theta. AD is nothing but AB sin theta. AB means what? 2A, length of dipole, 2A sin theta. AB is nothing but 2A sin theta. This is called perpendicular distance. So couple, what is couple or torque? C or torque is nothing but force into perpendicular distance AD. What is force? Force is nothing but QE into perpendicular distance 2A sin theta. This is nothing but couple. So you can write this as 2AQ into A sin theta, 2AQ into E sin theta. Couple, 2AQ into U sin theta. Let P dipole moment. Let P dipole moment. Dipole moment. What is the dipole moment definition? Q into 2A. This is called dipole moment. P is called dipole moment. P is called what? Dipole moment. Dipole moment is charge into distance between the length of the dipole. This is called dipole moment. Therefore, answer you are going to get finally, I am writing C is equal to PE sin theta. C is nothing but PE sin, couple or torque, nothing but PE sin theta. PE sin theta, or you can say couple torque is equal to couple or torque PE sin theta. And cross product manner also you can keep torque is nothing but P cross E. P is called what? Electric dipole moment. That is vector. Electric field is vector. Torque is a vector. This simple derivation, number of times asked in the examination 4 marks question, torque is nothing but force into perpendicular distance. You have to, only 2 steps you have to remember. F equal to QE, perpendicular distance 2A sin theta. For example, how to remember? Force is equal to QE, perpendicular distance 2A sin theta. Torque or couple is nothing but force into perpendicular distance. QE into 2A sin theta. Q into 2A. 2A is called length of dipole. Q into 2A, one more step, that is called dipole moment. Or directly you can write torque is nothing but equal to PE sin theta. 2AQ is P, PE is sin theta. That is how we are going to do this derivation. I am discussing first question and second question, which are very, very important gunshot questions for a board examination generally. But those who want above 55 or 60 sometimes should not take risk. For example, the toppers are there. They are, for example, you want 60 or 60. There are 4 questions are there, or 5 questions are there. All 5 questions you have to read. But today, lack of time, I am discussing most important questions. Luck is there, these things will appear 90%. Right. Now, next question. I am explaining derived expression. ఇవాళ నన్ను చావగొడుతున్నారు జనాలు. అది ఆ మైక్ ఇక్కడ పోయింది అసలు. నేను ఇలా మూయిందని నేను పడిపోతానండి, పళ్ళు రాలిపోతాను. చెప్తున్నాను, కష్టం అవుతుంది పెద్దవాళ్ళకి ఈ అరేంజ్మెంట్. ఇది మూవేడు పడిపోతాను నేను. డోర్ పెడితే ఇది మూవ్ అవుతుంది బాగా. ఇవాళతో నాకు వదిలిపోతుంది. 10 రోజులు బట్టి వస్తున్నాను, ఒక రోజు అని పోస్ట్పోన్ చేసుకుంటూ వస్తున్నారు. Right. The next expression, define intensity of electric field. Define intensity of electric field. Derived expression for it. Derived expression for electric intensity. Electric intensity due to a point charge. Due to a పైకి వెళ్ళిపోతుంది అంటున్నారు. Due to a point charge. Define intensity of electric field, derive the expression for intensity of electric field due to a point charge. How do you define intensity? First definition I am telling. Definition. Force experienced by unit positive charge or test charge. Unit positive charge. Force experienced by unit positive charge in the electric field. In the electric field is known as electric field strength. Is known as electric field strength at that point. Electric field strength at that point. Force experienced by unit positive charge in the electric field is known as electric field at that point. This is the definition. How will you write this definition in formula? E is equal to F by Q naught. Q naught is test charge. Q naught is very, very small. Q naught is very, very small. That is given by E. SI unit is a vector. Is a vector. SI unit of E is Newton by Coulomb. Newton Coulomb inverse or Newton by Coulomb. Derivation. Again, derivation I am doing in the next derivation. I am doing derivation for a point charge. So I am taking there is a charge here is in the electric field. This is producing electric field. I am taking one point P. Here Q naught I am keeping at a distance R. Q naught is test charge. Q is the charge around which electric field is there. So by Coulomb's law, you have to go for Coulomb's law. By Coulomb's law, what is Coulomb's law? F is nothing but force between these two charges. 1 by 4 pi epsilon naught Q naught by R square. R is the distance of separation. By Coulomb's law, force between the charges. What is Q? Actual charge around which electric field is there. Q naught is test charge whose electric field is very small. 1 by 4 pi epsilon naught Q naught by R square. By definition, E is equal to F by Q naught. I want to find electric field due to a point charge. I want to find electric field at this point Q naught. Q naught is very small. Q naught may be equal to 1 also. F by Q naught. Then what will happen? E is nothing but when you divide this by Q naught, 1 by 4 pi epsilon naught Q naught by R square by Q naught. Q naught gets cancelled. Electric field is nothing but 1 by 4 pi epsilon naught Q by R square. Electric field is nothing but 1 by 4 pi epsilon naught Q by R square. This is the derivation, intensity of electric field. This is asked in TS 16 and 22. Very long back asked and recently also asked. That's why I did this derivation. State Gauss law in electrostatic and explain its importance. State Gauss law in electrostatics. State Gauss law in electrostatics. State, this they are asking. State Gauss law in electrostatics. State Gauss law in electrostatics and explain its importance. And explain its importance. So this is also they are asking. State Gauss law. There are two laws are there in electrostatics. One is Coulomb's law, another is Gauss law. Gauss law is valid for symmetrical situations and continuous charge distributions and symmetrical cases. We are using Gauss law, where the solutions become simple by using Gauss law instead of Coulomb's law. So Gauss law, what is the statement? What is the Gauss law statement? Statement of Gauss law. Flux enclosed by a total electric flux. Total electric flux. Electric flux means electric lines of force. Enclosed by a closed surface. Enclosed by a closed surface is 1 by epsilon naught times the charge enclosed in surface, or total charge enclosed in the surface, it should be applicable to closed surfaces. Gauss law is applicable for closed surfaces. Electric flux enclosed by a closed surface is equal to 1 by epsilon naught times the charge. The formula, what is flux? This is flux, nothing but equal to Q, total charge Q, total charge enclosed by epsilon naught, Flux is also given by the formula integral E dot ds. Flux is also given by the formula integral E dot ds, but flux is main formula, this one you write, Q total by epsilon naught. For example, I am drawing a diagram. In this Q1 is there, Q2 is there, minus Q3 is there. Outside Q4 is there. This you should not take. What is flux formula is Q1 plus Q2 minus Q3 by epsilon naught. What is flux? Example, if you take Q1 plus Q2 minus Q3 by Q4, you should not take. Whatever charge is there inside only you are taking anamata. So plus charges will give outward flux, minus charges will give you inward flux. If you take dipole, flux will be 0. Plus charge minus charge only is there inside, total flux will be 0. Because plus charge outward, minus charge inward, total flux are equal to upward. So flux is scalar actually. Flux is scalar because charged by epsilon naught. Charge is scalar, epsilon naught is scalar. So what is the importance of Gauss law? We are writing importance of Gauss law in next page. What is the importance of Gauss law? Importance of Gauss law. Importance of Gauss law. It is valid for closed surfaces. Closed surface can be of any shape. Closed surface can be of any shape. It's valid for closed surfaces. Closed surface of any shape Gauss law relates electric field and charge. Gauss law gives the relation between electric field and charge. Electric field and charge. It is valid only for closed surface. Closed surface can be of any shape. Gauss law gives the relation between electric field and charge. It is valid for stationary charges and also moving charges. It is valid for, but main these two you write importance, very important. Gauss law gives the anyhow relation between electric field and charge. Even potential charge also it will give you. So this is regarding Gauss law, student. So actually, if time permits, lastly after long questions I will do axial line actually. The calculation of electric field and axial line of dipole, sometimes they are asking, that is asked in 22 actually in TS, 18, 19, 22. 18, 19, that is very important only, 18, 19, 19 and 22, TS 19 and 22. Leave about 17 and 18. TS 19 and 22, what is asked? Derive the expression for intensity of electric field at a point on the axial line of electric dipole. On the axial line of electric dipole. Just I will verify so much time is that because here, so lastly time permits I will do, but please read students for examination, even though I am unable to do, derive the expression for intensity of electric field at a point on the axial line of electric dipole. On the equatorial line of dipole also asked TS 20 actually. The axial line of dipole asked 19 and 22. So time permits, definitely lastly I will give hint to you. So now I am doing electric potential. I am doing selected questions. I am sorry students, I am doing selected questions. There are 5 questions are there, I am discussing 3. Electric potential and capacitance. Electric potential and capacitance. Electric potential and capacitance. So capacitance. This is very important. Electric field, electric potential and capacitance. In this compulsory one question is coming. So chapter, each mentioned chapter one question definitely comes. If you get these questions, what I am discussing, you are very, very lucky. 90%, 85%, 90%, these questions will come. But I am telling choice and fields, there you can get axial line of dipole also. Because you are preparing for torque, they may ask axial line of dipole also, electric field. 10% chances are there. But more important I discussed. So electric potential and capacitance, we are trying electric potential and capacitance. In this main thing is, first derived expression for capacitance of a parallel plate capacitor. For capacitance of a parallel plate capacitor, parallel plate capacitor. This is number of times is asked. There is expression for capacitance of a parallel plate capacitor. By definition, capacitance is given by charge by potential, students. Should remember in your brain, capacity, charge, if you are given to charge to conductor, potential rises. Charge directly proportional to potential. Charge Q is equal to CV, C is equal to Q by V. Q is equal to CV, C is equal to Q by V. Okay, students, capacitance. But parallel plate capacitor one device it is not capacitors connected in parallel. It is a parallel plate capacitor. It is a device. I am drawing diagram now. Answer. I am drawing diagram. Parallel plate capacitor. This is a plus plate charged by battery. There is a minus plate, same equal area. Minus plate, equal amount of charge. Area of each plate is A. Distance between the plates is D. Air is the medium. There is a uniform electric field is there. Between the plates. This is the parallel plate capacitor. Here charge is Q plus Q. Here charge is minus Q. But capacitance answer charge you won't get. But area is A. D is distance. What is the medium here? This is called uniform electric field. What is the medium you are taking first? Air is the medium here. Okay, students. This is the diagram. This is the diagram of parallel plate capacitor. So I am telling you definition. Capacitance is Q by V. We'll write later. So consider there are two charged plates. How they are being charged by battery. Two charged plates of each of area A separated by a distance D. Okay, uniform electric field exists between them. What type of field is there between them? Students, electric field or magnetic field or gravitational field? Uniform electric field exists between them. Okay, students. So this is the main thing, A separation. Now, by Gauss law, we have to start derivation how? Electric field derivation. By Gauss law. So Gauss law, you are used here by Gauss law. Electric field is given by the formula sigma by epsilon naught. What is sigma? Surface charge density. How you are getting sigma by epsilon? Some books. This plate will give you sigma by 2 epsilon naught. This plate will give you sigma by 2 epsilon naught in between them. You add sigma by epsilon naught is combination of sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Because one plate, according to Gauss law, will give you sigma by 2 epsilon naught anywhere. Second plate also will give you sigma by 2 epsilon naught. Both together will give you sigma by epsilon naught. Sigma by 2 epsilon naught plus sigma by 2 epsilon naught plus sigma by 2 epsilon naught, sigma by epsilon naught. But you can write directly what is sigma, epsilon naught permittivity, Gauss law, electric field. What is E? So I will write once again. By Gauss law electric field. This is called electric field. Electric field or electric field strength. E is given by sigma by epsilon naught. Next page I am doing derivation. Sigma means what? Surface charge density. Sigma means surface charge density. Sigma formula is nothing but charge by area. Q is the charge, A is the area of the plate. Sigma is given by the formula Q by A, the second equation. Then electric field can be written as sigma by epsilon naught. Sigma means Q by A, epsilon naught we get. This third step. Electric field is given by Q by A, epsilon naught. Q is the charge on each plate. Then potential difference. Let V be the potential difference between the plates. Let V be the potential difference between the plates. Then V, E relation. V is equal to E into D. Potential difference. PD means potential difference. Let V be the potential difference. Let V be potential difference between the plates. So V is equal to E into D. That is the relation between potential difference and electric field. This is the equation. Potential difference between V is equal to E into D. Now next step, very important step. By definition, capacitance. By definition, capacitance, C is given by charge by potential difference. C is given by charge by potential difference. Charge by potential difference. So C is equal to Q by V means E into D. E means what? E means Q by A epsilon naught. Q by A epsilon naught into D. Q gets cancelled. Ultimately, C you will get epsilon naught A by D. What is the parallel plate capacity formula? C is equal to epsilon naught A by D. Epsilon naught A by D. Epsilon naught is the permittivity of air. What is epsilon naught? You are right below. Epsilon naught in the examination. Epsilon naught permittivity of air. A is the area of each plate. Area of each plate. D is distance between the plates. So C, by definition, capacitance C is equal to Q by V. Basic definition of C is Q by V. Charge by potential difference. So these many steps are there. So write very carefully, practice number of times. This is a very, very important question. Next question I am discussing in this chapter, capacitors in series. Find the equivalent capacitance. Find the equivalent capacitance. Equivalent capacitance when capacitors are connected in series. When capacitors are condensers. Capacitor, condenser, one and the same, are connected in series. Are connected in series. Connected in series. Find the equivalent capacitance when capacitors are connected in series. Student. Answer. So there are number of capacitors, one after other. This is plus plate, this is minus plate. Again, it connected to second plate. First one is connected to second one is connected to first again. C1, C2 and C3. All are having equal charge, the C3. Okay, students, minus Q plus Q and minus Q plus Q. Like that, it is connected to a battery. Connected to a battery of potential difference V here. Each capacitor we have potential difference V1, V2 and V3 now. Capacitor C1, C2, C3 are connected in series now as shown in the figure. So how to do this derivation? Let the applied potential difference now. So applied potential difference V should be equal to V1 plus V2 plus V3. V is equal to applied potential difference V should be equal to V1 plus V2 plus V3. So you are right theory part here, how they are connected in series. How they are connected in series. What is series you have to explain. First plate is connected to second, second is connected to first, second connected to first. First plate, last plate connected to the potential difference. This is called series. In series, charge will remain same. In series, charge will remain same. Charge will remain same. I am writing briefly, student. This is your done. Will remain same. So V is different. What is different? Potential difference is different. PD is different. Therefore, by definition, what is definition? By definition, C is equal to Q by V. C is equal to Q by V. Equivalent capacitance series you say Q is equal to VV. So what is V is equal to Q by CS. What is CS? Equivalent capacitance. Then similarly V1. What is V1? Q by Q remains same C1. V2 is equal to Q by C2. V3 is nothing but Q by C3. What is CS? Equivalent capacitance. So left side, right side you are equating what you are going to get. Next page I am drilling. So left side V is equal to V1. This is the basic equation you have to remember. Q by CS nothing but Q by C1 plus Q by C2 plus Q by C3. What is CS? Equivalent capacitance. Q common. So it implies that Q by CS is nothing but equal to Q into 1 by C1 plus 1 by C2 plus 1 by C3. Q gets cancelled. 1 by CS is nothing but 1 by C1 plus 1 by C2 plus 1 by C3. What is CS? Equivalent capacitance. CS is called equivalent or combined capacitance. Equivalent capacitance of all capacitors together. Equivalent capacitance of all the capacitors. That is CS. So this is the formula when you are connecting in series. This is the second question I am discussing, but one more question is there, derivation of potential due to a point charge. So that you learn yourself. Then I am explaining moving charges and magnetism now. Magnetism, moving charges and magnetism. Next chapter. Moving charges and magnetism. Moving charges. In this photo, they are asking questions. Moving charge and magnetism. What is the first question in this? State and explain Biot-Savart law. State and explain Biot-Savart law. Biot-Savart's law. State and explain Biot-Savart's law. This is a very important question. So I am explaining this. There is irregular wire carrying current like this. Paiking వెళ్ళిపోతుందండి నాకు అర్థం కాదు. అంటే పనిష్మెంట్ లా ఉంది ఇది. Consider DL element. This is the current carried, and at a point P you select at a distance R. The angle between them is theta. I am taking current element. IDL, small element. I am taking small element DL, current element. Is a regular wire carrying current. So I am writing the law. The current element is law. Magnetic field. Whenever current is there, what is Oersted says that is there is a magnetic field around it. When current carrying wire is there is a magnetic field around it. The small magnetic field dB is called small magnetic field. Small magnetic field due to current element IDL. Therefore, this dB is proportional. More the current element, IDL is vector. dB is proportional to IDL. Of course, distance is proportional to 1 by R square. What is R? Distance from center of element to the point P. That is called R. And directly proportional to sin theta. Okay, students. Then dB is proportional to IDL sin theta by R square. dB, if you remove a proportionality, you will get a constant mu naught by 4 pi IDL sin theta by R square. This is the formula. Ideal. What is mu naught? Permeability of air. Mu naught is what? permeability of air, magnetic constant, its value is 4. So what is, actually I explained the law only, diagram is here, you can see, but you have to write description. What is R? You have to write what is R. What is R? You have to write, students, I am explaining here, what is theta also. R is nothing but distance of the point P from the center of the element. What is R? Distance of the point P from the center of the element, current element. What is theta? Theta is angle between ideal and R. Theta is angle between ideal and R. This is called empirical law, not exact law. Only small magnetic field. Total magnetic field could be a wire. You have to give limits from here plus infinity to minus infinity. The long wire means mu naught by 4 pi ideal sin theta by R square. This is called Biot-Savarit's law. Biot-Savarit's law. Very important law. Eisenstein says that current carrying conductor always have magnetic field around it. Now next question. Derive the expression for magnetic dipole moment of revolving electron. This is often they are asking. Derive the expression for magnetic dipole moment. Magnetic dipole moment of revolving electron. Magnetic dipole moment of revolving electron. Derive the expression for magnetic dipole moment of revolving. This is very, very important. Number of times is asked. Biot-Savart also number of times asked. So I am taking a revolving electron. Electron is revolving with a velocity v. The radius is r. Electron is revolving with a velocity v. Electron is moving anti-clockwise like this in a circular orbit of radius r. So here an electron of charge E is revolving in an orbit, in circular orbit of radius r with a velocity v. Circular orbit of radius r with a velocity v. What is current? Charge by time period. What is the magnetic moment definition? First I am writing current. Current is produced. Current I is produced due to the revolution of electron. Current travels opposite the direction of electron. If electron is moving anti-clockwise, current will be clockwise. Current I is produced due to revolution of electron. Electron is revolving anti-clockwise, current will be clockwise. Current is always upward direction of electron. By current elasticity, what is the definition of current? I'll do in next one. By definition, current is given by what? Charge by time period. T is called time period. Time period is given by one revolution. It covers a distance 2 pi r with a speed v. Time is given by 2 pi r by v. Okay, students, this is time period. Then current equation, what you get? Charge by 2 pi r by v. So I will get EV by 2 pi r, current equation. By definition, magnetic moment. Magnetic dipole moment. Magnetic moment is current into area. Current is nothing but EV by 2 pi r. Area means pi r square. R square gets cancelled. Pi gets cancelled. Though magnetic moment of a revolving electron, you will get EVR by 2. Magnetic moment of revolving electron, you are going to give you EVR by 2. E is charge, V is velocity, R is the radius. Magnetic moment of revolving electron, EVR by 2. Here 2 points you have to observe. Main definition of current elasticity, charge by time period. Time period is 2 pi r by V. First current expression you get. But you should remember magnetic moment basic definition also. Magnetic moment current into area. Magnetic moment is a vector because area is a vector. Current is scalar. Magnetic moment is a vector. We'll find the direction by right hand rule. Magnetic moment is current into area. Current is EV by 2 pi r, area of the circle. Why pi r square you are taking? Area of circle is pi r square. Then you are going to get EVR by 2, where E is charge of the electron, V is velocity of the electron, R is the radius. So this is magnetic moment of revolving electron. Students, please read yourself Ampere's law. So after explaining long question, time permits, I will tell, or you have to read that the Ampere's law also very, very important. State and explain Ampere's law, or using Ampere's law, derive the expression for magnetic field due to a long straight wire. Magnetic field due to a long straight wire is B is equal to mu 0 I by 2 pi r. Magnetic field due to a long straight wire is mu is equal to mu 0 I by 2 pi r. Or state and explain Ampere's law. What is Ampere's law? The tangential line integral of tangential component of magnetic field around a closed path is equal to mu naught times the current. Is equal to mu naught times the current. That is Ampere's law. I am just giving statement only. I am not writing on the board. The line integral of tangential component of magnetic field around a closed path is equal to mu naught times the current bounded by the surface. Number of conductors may be there in the boundary. Integral B dot dl you will take I1 plus I2 minus I3 minus I4, like that you will write and explain Ampere's law. Ampere's law is used for symmetrical element like straight conductors only. Biot-Savart law is used for irregular conductors. You can make into circular coil also. You can find out magnetic field by using integration using Biot-Savart law. So this is moving charges and magnetism. I am telling next chapter, electromagnetic induction. Electromagnetic induction. Electromagnetic induction. In this 4 marks question is coming, is called EMI, electromagnetic induction. What is electromagnetic induction? Changing magnetic field or magnetic flux produces induced current. Changing magnetic field or magnetic flux produces induced current. Changing magnetic field or magnetic flux. Changing magnetic field or magnetic flux produces induced current. That is what Faraday introduced. But what Einstein introduced? When electrons in motion, in conductor electrons will be there in motion, produces magnetic field. He taught reverse. When the magnetic field is changing or magnetic flux is changing, why not be current is there? That current is called induced current, that will be momentary. That is called electromagnetic induction. In this, we are first discussing about electromagnetic induction. First important question we are discussing, magnetic induction. Describe the ways in which eddy currents are used to advantage. Theoretical question they are asking very much number of times. Describe the ways in which eddy currents are used to advantage. In which eddy currents are used to advantage. So what are eddy currents? First we are define what are eddy currents. When large metal pieces of conductors, when large metal pieces of conductors, metals means conductor, are subjected to change in magnetic flux. This is very important. Change in magnetic flux or magnetic field. Change in magnetic flux. Induced currents are generated. Induced currents are generated. generated. These are eddy currents. These are which are occupied in metal circulation, just like wobbles will be there. These are eddy currents. Induced current means these are eddy currents. What are eddy currents? When large metal pieces are subjected to change in magnetic flux, induced currents are generated. These are eddy currents. That is the definition of eddy currents. What are the uses of eddy currents? I am explaining next page. Uses. First, you write each. I will explain. Magnetic braking in trains. Generally, normal braking is there. For a normal mechanical, for example, a vehicle is there, you are applying mechanical brakes to stop the vehicle, train or bus or your scooter. But in foreign countries, there is other way is there. What is the other way? When you are using soft iron pieces, when electromagnets are activated in rails, induced currents are generated. Induced currents are generated because Earth's magnetic field will be. Induced currents are generated. These currents will oppose the motion of the train. So magnetic braking is done like this. When electromagnets are activated in rails, mainly thinking induced currents only you have to explain. Electromagnetic damping. The pendulum oscillating in magnetic field. Oscillating in magnetic field is magnetic field. Damping means amplitude comes due to induced currents in galvanometers also. The pendulum oscillates in magnetic field. Damping comes due to induced currents. That is called electromagnetic damping. Next page, induction furnace. So at least you write side headings, you will get 2 marks first. I am telling you, induction furnace. If you explain, you get 4 marks because they are 4 marks question. You write reason is induction currents only. Induction furnace. High frequency alternating current is passed through coil. Eddy currents are generated. With high frequency AC, with high frequency AC alternating current is passed through a coil. Eddy currents are generated. And heat the metal. This is called furnace. Heat the metal. Lastly, power disc. Electric power meters. Electric power meters is very simple. The shiny metal disc in electric power meter. Shiny metal disc in power meters. Power meter rotates due to eddy currents. Everything is you write with eddy currents. I think they will give full marks to you. Sometimes it will have advantage of braking, advantage of stopping and dampening and all that. This is the uses. They are asked TS 17, 18, 22, 23, 24. I am telling TS 17, 18, you leave it 22, 23, 24. 3 times continuously asked 22, 23, 24. We are like 25 asked or not, we don't know. I am doing one more question. Motional EMF you derive, that is asked, not asked in TS. Magnetic energy stored in a solenoid. Obtain the expression for magnetic energy. Obtain the expression for magnetic energy stored in a solenoid. Magnetic energy stored in a solenoid. Magnetic field in a solenoid. Obtain the expression for magnetic energy stored in a solenoid is told. There are 2 ways of doing this is solution. So stored in a solenoid. In a solenoid, induced EMF is in a solenoid. Solenoid is a long straight wire forming. This is called solenoid. This is called solenoid carrying current. So a solenoid induced EMF is given by minus inductor. L is called inductor di by dt. L di by dt. This is called induced EMF, rate of change of current, L di by dt. L is called self-inductance. So power, here power generated, power P is nothing but induced EMF into current. Induced EMF into current, voltage into current. Therefore, you will get L di by dt into I. This is called power. What is energy now? Small energy du is nothing but power into dt. Power into d. Energy is nothing but power is energy by time. Energy is power into time. Power means minus Li di by dt into dt. dt gets cancelled. You are going to get du is nothing but minus Li di you will get. Minus Li di. L is called self-inductance. Du. U is energy. I am doing integration. Integral du. L is constant. Integral I di. By integration, magnitude of energy I am taking. So Li square by 2 I will get. Li square by 2. Magnetic energy magnitude half Li square I am getting. Half Li square. This is up to this, if you do it is enough actually. Half Li square. Magnetic energy stored. What is L? Self-inductance. I is current. Half Li square. Magnetic energy stored is half Li square. For solenoid, still if you want to extend, some books will give you for solenoid. B is equal to mu0 In. N is number of turns per unit length. mu0 In. I is given by B. I is equal to B by mu0 N. Magnetic field by mu0 N. Okay, students, wherever N is there. Self-inductance of solenoid is given by formula mu0 N square A into L. These 2 equations, if you can substitute, you substitute in the equation energy half Li square. Wherever Li square, half Li square is take. What is half L? L means mu0 N square A into L. mu0 N square A. L is length of the conductor. Small L is length of the conductor. Capital L is self-inductance. Into I is nothing but B by mu0 N. So small N square gets cancelled. Li square, square is Li square. B square by mu0 square N square will come. N square gets cancelled. mu0 square gets cancelled. Energy stored will become B square by 2 mu naught into area into length. Area and length is called volume. This is called magnetic energy stored in terms of magnetic field. You can write This is the expression for magnetic energy stored, or up to half LA square you can do. Different books is giving a different way. Instead of discussing atoms, now I am discussing semiconductors first, student. Time permits, I will discuss in atoms. Student, orally I am telling, in atoms, what are the limitations of Bohr's theory? That you are learning in chemistry. What are the limitations of Bohr's theory of hydrogen atom? This asked 18 and 22, TS 22. What are the limitations of Bohr's theory? Limitations means drawbacks. It could not explain the fine spectral. What is the drawbacks? Intensity of the spectral lines is not explained by Bohr. He says circular orbit may be elliptical. Bohr could explain only spectrum due to hydrogen atom, but not due to element more than atomic number Z is equal to 1. He could not explain about helium and lithium successfully. Bohr explained only for hydrogen atom, but not for helium or lithium. Intensities of spectrum cannot be explained. So those are the drawbacks. Bohr's hydrogen. He says orbits are circular, but they may be elliptical. After that, Sommerfeld says these are the drawbacks of Bohr's theory. Explain different spectral lines of hydrogen atom. Lyman, Balmer, Paschen, Brackett, Fund series. This is very important. Asked in the examination, because the atoms you can read yourself. Like chemistry, I am doing last chapter, that is semiconductors. Short questions, semiconductors I am doing. Semiconductor electrons I am doing. In this first, explain half-wave rectifier. Explain what is rectification, what is rectification, what is rectification, explain half-wave rectifier, explain half-wave rectifier, explain half-wave rectifier. This is very important. There are two important questions are there in this. One is on gates, another is on rectifiers. What is rectification? Explain half-wave rectifier. This is semiconductors, very important chapter. What is rectification? I am telling what is rectification. Conversion of AC to DC. Conversion of AC means alternating current to DC is called rectification. Is called rectification. That can be done by half-wave rectifier. What the diagram consists of half-wave rectifier? I am drawing diagram. I am drawing diagram. There is a diagram. Here one diode is connected. Here one load resistance is connected. Okay, students? 1 minute. This is called transformer. Here AC is connected. AC signal. This is called AC input. This is called AC input. This is diode. Diode. This is load resistance across which you are measuring output. You are measuring output. Diode. One diode is used. So I am telling you briefly. Half-wave consists of one diode, as shown in the figure. Half-wave rectifier, circuit 1 mark will be there. Definition 1 mark will be there. Half-wave rectifier consists of one diode. Consists of one diode D, as shown in figure. As shown in figure. Connected to input. Connected to input. This is called primary. This is secondary of transformer. This is AC connected. What will happen? Working. What is the working? What will happen? When AC input, when AC positive cycle input is connected, when AC positive cycle, when AC input, with AC input, positive half cycle, positive half cycle, positive cycle is connected, diode becomes forward bias. Diode becomes forward bias. In forward bias, current goes through load. Current goes through load RL and output is developed. For negative half cycle, diode will not conduct. For negative half cycle, diode will not conduct. Diode D will not conduct. Output is not developed. That means for positive half cycle, it is getting developed. For a negative half cycle, it is not getting developed. Again, for positive half cycle, diode will conduct. For negative half cycle, diode will not conduct. So continuity will not be there in DC waveforms. So I am drawing waveforms next. This is called working. What is the waveforms? I am drawing next page waveforms. I am drawing waveforms. What is waveforms? Input AC waveform will be drawn by positive, negative. Students, again positive, negative. Like this. This is input versus time. Output will be how? His output will be only positive will be there, negative won't be there. Again, positive will be there. So positive, negative, positive, negative. Positive, negative, positive, negative. Positive, negative, positive, negative. Positive, negative will be there. Positive cycle, exactly this. This is called output waveforms. You are getting not continuity. What is the efficiency formula? 0.406 RL by RL plus RF. What is RL? Load resistance. What is RF? Diode resistance. What is RF? Diode resistance. So percentage of efficiency is only 40.6%. Output is only 40%. This is pulsating DC, not perfect DC. This is called pulsating DC. This is called half-wave rectifier. What is the drawback of half-wave rectifier? Continuity you are not getting. Even though you are getting on positive side, continuity is not there. This is rectified by full-wave rectifier. So next, explain rectification. What is full-wave rectifier? Explain full-wave rectifier. Full-wave rectifier. Explain full-wave rectifier and define rectification. Define rectification and explain full-wave rectifier. Explain full-wave. What are the advantages? So answer I am writing full-wave rectifier. What is full-wave rectifier? Full-wave rectifier. I am writing full-wave rectifier diagram to you. Full-wave rectifier. There are two diodes you are connecting. So here two diodes are connected. Negatives of diodes are connected together from center. I'll bring down the figure. Here AC input is considered. Here center tapping is taken. Special center tap. This is called center tap. Center tapping is taken from this point. Not connected. Here one connection is there. Here one connection is there. Here the one point, here another point. Here load resistance is connected. Here load resistance is, here output is taken. Here output is taken. Two diodes are connected. This is called, C is called center tap. This is A, this is B. Okay, C is called center tap. C is called what? Center tap. Center tap. With respect to this will become waveforms given to A and B are out of phase. With respect to C, what is a full wave rectifier? I'm explaining with respect to center tap. With respect to center tap, waveforms given to A and B are out of phase. Input waveforms were out of phase. Two diodes are used here. Full wave rectifier, how many diodes are used? Two diodes are used. So input waveforms are two types here. So one input waveform given to this, it will be like this. A input waveform. So A input waveform. B input waveform, how it will be? It will be out of phase here. This will be like this. Here plus is given, B minus is given. To be given like this. This is input waveforms A and B. So here due to this, what will happen? Due to this, diode, there are two diodes. I'll go to previous slide. Two diodes are there, diode D1, diode D2. Okay, so due to this, diode D1 becomes conducting for input A. The positive half cycle is connected. Diode becomes conducting from input A. Diode D1 becomes conducting for input A. Diode D2 will become reverse bias. And D2 becomes conducting for the positive half cycle of B. So now you are right like this. So for due to this, D1 becomes conducting for input A and but not conducting for B. Due to B, diode D2 becomes conducting. What is the meaning of this one is, I'm telling you, when A positive is given, B negative is given. When A negative is given, B positive is given. At a time only one diode will work. Current will flow in load resistance and output is developed. During both the cycles. So I am drawing waveforms, output waveforms here I am drawing. So I will show you output waveforms here. Output waveforms you see. Output waveform you see here. Output waveform how you are going to get is continuous. I am going to get continuous output waveforms here. V output versus time you will get continuously. That is the advantage of full wave rectifier. Efficiency is given by formula 0.812 RL by, at a time only one diode will work, forward resistance of diode. Percentage of efficiency. Sorry students, I did not do very efficiently full wave rectifier, but I told you method. So what is the input with respect to center tap? A waveform becomes positive, B will become negative. So at a time A is given, diode is given positive half cycle, B is given negative half cycle, A conducts, B will not conduct. Next time what will happen now? Next time when negative is given to A, positive will be automatically given to B, then diode D will conduct. So whenever positive is given for B, negative is given to A. When positive is given to A, negative is given to B. Because of this diode, only one diode at a time will be conducting, but both the diodes will conduct in a cycle. The current will go in same direction, output voltage will be developed. This is what half wave rectifier. Distinguish half wave rectifier and full wave rectifier. They are asking often. They are asking distinguish half wave rectifier. This is very easy. You need not draw diagram. Distinguish half wave rectifier, half wave rectifier, and full wave rectifier. And full wave rectifier, half wave rectifier and full wave rectifier. Distinguish half wave rectifier and full wave rectifier. You write only differences. I am reading out differences. Here half wave and full wave. Right? Tabla form. Half wave, full wave. Only one diode is used here. One diode. I am writing here. Two diodes are used. Two diodes are used here. There is no center tap here. There is no center tap. There is center tap. Center tapping because two diodes are there. Center tap. Efficiency is 40.6% here. Here efficiency is 81.2% here. Double. These are the main differences between half wave rectifier. One diode is used, two diodes are used. Like that, you can write the waveforms, draw waveforms and all that. You can do it. This is the difference between half wave and rectifier. Last question. What is NAND gate? Last question, short question I am discussing. NAND gate. What are NAND gates? What are universal gates? What are universal gates? What are LEDs also they are asking very rarely. What are universal gates? What are universal gates? Give their truth tables. Give their symbols and truth tables and truth tables. So NAND, what is the answer? NAND and NOR gates are universal gates. Universal gates. NAND and NOR gates are universal gates. NAND and NOR gates are universal gates. Symbol, NAND gate symbol I am writing. This is NAND gate symbol. Circle you are keeping. A, B, Y is equal to AB bar. This is NAND gate. This is NOT gate. NAND, not plus AND. What is NOR gate symbol? NOR gate symbol, this is A, B, Y is equal to A plus B bar. These are called universal gates. By using two NAND gates, I can get AND gate. Okay, students? Okay, students, NAND gate and NOR gate. What are the truth tables? Truth tables. I am giving truth table. Truth table with Bell algebra. Truth table. NAND gate. NAND gate. I am giving two inputs. 0 and 1 is there. AB and input AB bar. A 0, B 0. A into B 0. 0 into 0. 0 bar is 1 here. 0 into 1. 0 into 1, 0 bar, that is 1. 1 into 0. Again 0 bar, that is 1. 1, 1. Y is equal to 1 into 1, 1 bar, that is 0. Again I am telling 0, 0. 0 into 0. A is 0, B is 0. 0 into 0, 0. 0 bar is 1. 0 is low, 1 is high. 0 into 1, 0. 0 bar is 1. 1 into 0, 0. 0 bar is 1. 1 into 1, 1 bar is 0. Similarly, NOR gate, this is called truth table. NOR gate. Here, A, B, Y. Y is nothing but A plus B whole bar. R gate opposite anamata. R gate opposite. A 0 0 0 plus 0. Y nothing but equal to 0 plus 0 0 bar, nothing but 1. 0 1 0 plus 1 1 bar 0. You are not multiplying here. 0 plus 1 is 1, 1 bar is 0. 1 0. 1 plus 0 is 1 bar, that is 0. 1 1. 1 plus 1 1. 1 plus 1 not 2. 1 plus 1 1 only. 1 bar, I plus I 0. This is the truth table of NOR gate. By using 2 NOR gates I can get AND gate. By using 2 NOR gates I can get OR gate again. By using 2 NOR gates in series we get AND gate. By using 2 NOR gates in series we'll get OR gate. This is the end of short questions. I think 75% to 80% of questions I discussed in short questions, except atoms. Atoms I told orally. In ray optics and wave optics, 1 or 2 questions I left. Simple microscope, something like that. But otherwise I explained 70 to 75% questions of blueprint. Short questions completely. Second year short questions. We'll shortly 5-10 minutes we'll start long questions. Important long questions will finish. Students, we are doing LAQs now. We are doing LAQs. Long questions. Long questions of physics. Second year. Long questions of physics second year. Long questions. We are doing first. I am doing selectively. There are strings is there. Strings I am leaving. Please leave. Closed pipes, open pipes, Doppler effect. I am doing now closed pipes, open pipes and Doppler effect. So discuss the mode of vibration. Discuss in waves you are getting. Waves chapter. Waves one long question will come. Discuss the mode of vibration in open pipes. In open pipe. Discuss the mode of vibration in open pipes. Answer. Open pipe is a pipe open at both ends. Open at both ends. Open at both ends. This is called open pipe. Open pipe is a pipe open at both ends. In open pipe, longitudinal stationary waves are formed, sound waves. In open pipe, longitudinal stationary waves are formed. Longitudinal stationary waves are formed. Longitudinal stationary waves are formed in open pipe. Stationary wave means what? In which you will get nodes and antinodes. Two waves traveling in opposite direction superpose each other. The wave is confined to limited region. So we are going to get node where displacement is 0, antinode displacement is maximum. Distance between two consecutive nodes is lambda by 2. Distance between two consecutive antinodes is also lambda by 2. Distance between node and next antinode is lambda by 4. What is lambda? Wavelength. What is lambda? Wavelength. So I am going to draw a diagram, discuss different modes of vibrations in open pipes. Open pipe example is flute. We are playing flute. Flute is open at both ends. Flute is open at both ends. Example is flute. Example is flute. Flute. So I am drawing diagrams now. So fundamental frequency, we are drawing diagram. This is the diagram open pipe. Some will keep horizontal. Length L fixed. I am blowing air or shooting for frequency N1. I am drawing a diagram. You have to plan the diagram such that antinode is formed here. Node is formed. This is called fundamental frequency or first harmonic. This is called fundamental frequency or first harmonic. This is called fundamental frequency or first harmonic fundamental frequency or first harmonic. This is given by the frequency Antinode, node here, N is called node, antinode. It consists of two antinodes and one node. Okay, L is the length of the pipe. Okay, I'll draw second diagram. First, I'll work out for this fundamental frequency. L is length of the pipe. Don't write general formula. This is better. L is length of the pipe. Let V is velocity of sound. Let V is velocity of sound. V is equal to L lambda. So fundamental frequency or first harmonic. Let N1 is the frequency. N1 is first harmonic frequency. First harmonic frequency. First harmonic frequency. L1 is first harmonic frequency. L1 is first harmonic frequency. Midpoint node is formed here. Decision between node and antinode is lambda by 4. L will be equal to now lambda by 4 plus lambda by 4. L is nothing but what? This is the antinode to node lambda by 4. This is lambda by 4. So it implies that L will be equal to lambda by 2. L will be equal to lambda by 2. It implies that lambda value is nothing but 2L. Lambda value is nothing but 2L. How to find frequency? N1 is nothing but V by lambda. V by lambda, because V is equal to L lambda. That is nothing but V by 2L. Therefore, fundamental frequency or first harmonic frequency, we are going to get the formula V by 2L. Fundamental frequency. This is fundamental frequency. Now I am doing second harmonic also. I am showing you. This is called diagram for first harmonic. So how it looks like, some people will write all diagrams at one place. All diagrams at one place. Here I am drawing second harmonic, third diagram, because you know this method now. I'll do quickly the thing. Second harmonic frequency. Second harmonic frequency. Now I am doing what is second harmonic frequency. Second harmonic frequency. Second harmonic frequency. It's called first overtone, they'll call, but don't write overtones. First fundamental frequency or first harmonic. Next one is called second harmonic. You will get first harmonic, second harmonic. All harmonics you will get in open pipes. Second harmonic, same diagram, same length you are using. Diagram out will change. Your full loop will be there. Same length you are taking. Tuning fork frequency, second frequency you are taking. So you are going to get antinode, node, antinode, node, touching point, and antinode. So this is second harmonic frequency. This is second harmonic. Second harmonic. So I will draw third harmonic here to you. In between that working I will do. What is third? Up to third harmonic you have to do. What third harmonic you will do? Just like you have to plan. You have to do like this. This is like L. This is antinode. This is node. This is antinode. This is node. Antinode, node, and antinode. Just opponents always will get antinode. Antinode. This is called third harmonic. This is called third harmonic. N3. Second harmonic. N2. So how many? Lambda by 4, lambda by 4, lambda by 4. Second case you are going to get L is equal to 4 into lambda by 4 you will get. Earlier you got 2 into lambda by 4. Now you are going to get L is nothing but equal to lambda. Lambda is decreasing now. Lambda becomes L. N2 will become V by lambda. N2 will become V by lambda. N2 will become equal to V by L. N2 will become equal to V by L. Or N2 is equal to 2V by 2L. 2V by 2L. Here when you are doing this, in this you are going to get, okay students, here 6 into lambda by 4 you are going to get. 6 into lambda by 4. Because lambda by 4 sets 6 are there. So if you bring down the diagram you will know. So 6 into lambda by 4. So lambda will become 4L by 6 or 2L by 3. Therefore N3 V by lambda V by lambda or lambda, V by lambda, V by 2L by 3 you have to get. So third harmonic 3V by 2L you will get, 3V by 2L. So N1, so you are going to get ratio of frequencies. What is the ratio of frequencies? Finally I am doing N1 is V by 2L, first harmonic, N2 is 2V by 2L, N3 is 3V by 2L, denominator is 2L. Therefore N1 is to N2 is to N3, nothing but 1 is to 2 is to 3. We get even and odd harmonics. You are getting both even and odd harmonics in case of open pipes. I am thinking that you have some idea because exams are fast approaching. So now very less students will study after first or second the physics. Generally third onward they will go to languages, because generally language they will read at the last, generally 1 month, 15 days, 1 month they will read. There is a lot of time they need from March 1st to 4th or 5th they read language. That's why I want to complete, I want to give idea, the idea of preparing for the answer, how to write answers without mistake, how to draw legibly the diagrams I am doing. Even though my presentation diagram is not very good, I am trying to explain the concept to you so that it go into your mind when you are revision. Those who are hearing this YouTube lesson, this is open pipes. I am telling now Doppler effect I will do you. There is closed pipes is there, strings is there. Please read. I am doing Doppler effect. What is Doppler effect? Second long question from waves is Doppler effect. So Doppler effect, I am doing Doppler effect. But in this one problem they are asking student, in this problem they are asking fundamental frequency, they are asking by using V by 2L. This is the fundamental frequency. So length is given 85 centimeters or 70 centimeters. Velocity of sound 330 meter per second, and calculate fundamental frequency. Like this problem is asked. So you can easily do it. 85 meters convert into 0.85 meters, something like that. Substitute, you will get the frequency. This problem is asked in a long question. Under open pipes, 85 or 70, some number is given. Length 85 centimeters or 70 centimeters. Closed pipes, sometimes they are asking, sometimes open pipes they are asking. In closed pipes, denominator will be 4L. In closed pipes, only you will get odd frequencies. 1 is to 3 is to 5 you will get. Closed pipes, you will get only odd harmonics. You will get only odd harmonic. First harmonic, third harmonic, fifth harmonic. But open pipes will get first harmonic, second harmonic, third harmonic, fourth harmonic, even and odd harmonics you are getting. Open pipe sound is rich sound. Closed pipe is sound is not that rich sound. So when compared to open pipe. Okay, so we are doing lastly the Doppler effect. Strings, formation of stationary waves in strings also sometimes they are asking, discuss the laws of transverse waves like that. But I am leaving now. I am explaining one on stationary waves, one on Doppler effect. Doppler effect. What is Doppler effect? Long question. What is Doppler effect in sound? We discussed Doppler effect in short question also, that is light. What is Doppler effect in sound? Obtain the expression for apparent frequency. Obtain the expression for apparent frequency. Expression for apparent frequency of sound when source is in motion, and observer at rest. Source is in motion with respect to observer at rest. Source in motion with respect to observer at rest. With respect to observer at rest. With respect to observer at rest. This one only they are asking in the examination. Source is in motion, observer at rest. Doppler effect. What is Doppler effect? Answer. Definition. Train is coming towards platform. So there is a passenger is there on platform, rest. Source is in motion, coming towards the platform, frequency increases, apparent frequency increases. The same train recedes away by whistling, the frequency decreases. So what is the definition? The apparent change in the frequency, of sound note of sound when source is in motion, when source and observer, general definition, when source and observer are in relative motion to each other, are in relative motion to each other, that means both may move, one may be at rest, other may move. The apparent change in the frequency of sound when source and observer are in relative motion to each other is called Doppler effect. Is called Doppler shift or Doppler effect. Doppler effect or Doppler shift. This is the definition. I am doing the derivation now. How will you do the derivation? First part, source is moving away from observer. Source is moving away from observer at rest. Source is moving away from observer at rest. He is taking, his observer is at rest. Now this is source, train. Initially source is at rest only. Observer at rest, always observer at rest only. Now source is here. Let V be the velocity, distance of separation between them. We are giving you L. So L is the distance of separation between source and observer initially when they are at rest. When both are at rest, when they are at rest. Let V be the velocity of sound. V is velocity of sound. Velocity of sound is very high. Let V be the velocity of sound. True frequency is given by V by lambda. What is true frequency? What is time taken? To one wave, source releases one wave to reach here. Wave is released here. Time taken by the wave to reach observer. Time taken. T1 is nothing but L by V. T1 is L by V. This is first equation. T1 is nothing but L by V. This is first equation. T1 is L by V. Okay, I am doing now when observer is moving away. Source is moving away. Now source is moving away like this, new position now. This is new position of the source. This is observer, this is source. This is new. This is L. So it is moving. This is new position, S dash, new position of the observer. Okay, students, it's moving with a velocity. What is the source? Let source is moving with a velocity Vs. Let Vs is the velocity of source. Moving away from observer. Is observer at rest. Then what will happen? Distance will change now. What is the distance now? So by the time one cycle goes here, it will move in this time. What is SS dash? Vs into time period. What is the distance SS dash? Vs into time period. Now what is the length between OS dash? OS dash means L plus Vs into T. L plus Vs into T. This is called OS dash. SS dash is Vs into T. So this much distance is moving in a time, one cycle. By the time one cycle goes here, it moves distance Vs into T. Okay, students? Then apparent frequency, how to find out? So no, not apparent frequency. time period, apparent time period, apparent time period now, t dash, how to find time period? One cycle time taken is time taken t plus, okay students, L plus Vs into t by velocity of sound. What is time taken? So distance is number, because earlier time taken we told L plus L by V we told. Earlier what we told? L by V we told. L by V we told. Now we are telling L plus Vs into T by V. This, what is this time period? Actual time period plus. So already one cycle has moved. By the time the second cycle has to move, how much time taken? First cycle time period is time. First cycle time is taken T plus additionally L plus Vs into T by V. Velocity of sound remains constant. So what is so not T dash, this is not T dash, T2. Time taken is T2 plus T2. This is time taken. T2 is T plus L plus Vs to T by V. What is apparent time period? I am telling. Apparent time period, see, small, very carefully you do. Apparent time period is nothing but T2 minus T1. T2 minus T1. What is T2 minus T1? What is T2? This one, T plus L plus Vs into T by V minus L by V. This is called apparent time period. T dash is nothing but T plus L by V plus Vs into T by V minus L by V. Plus L by V minus L by V gets cancelled. Apparent time period I am writing here. What you are going to get? T plus Vs into T by V. T dash is nothing but T common 1 plus Vs by V. But I will do generally how to find apparent frequency. How to find apparent frequency? I am writing here only. Apparent frequency now. Apparent frequency N dash is nothing but 1 by T dash. Apparent frequency is nothing but what? 1 by T dash. Here you can write T into V plus Vs by V you will get here. Don't write binomial expansion, nothing here. N dash is equal to 1 by T dash. 1 by T dash you do it. So I am doing 1 by T dash. So 1 by T dash is called N dash is 1 by T dash. So 1 by T dash will become 1 by T original frequency into V by V plus Vs I will get. V by Vs. If I reverse this, V by Vs. So 1 by T dash is called N dash. This is called true frequency V by V plus Vs. So this is the formula you are using for problems. N dash is equal to N into V by V plus Vs. When apparent frequency is less than true frequency. Okay students, right. When source is moving towards B, you have derived actually. When source is moving towards observer at rest. Similarly you can write here T2, what will happen? T2 time period T plus L minus Vs into T by V you will get. Similarly, therefore apparent time period you will get it as T into V minus Vs by V you will get. It implies that N dash is nothing but N into V by V minus Vs you will get. Instead of plus you take minus sign. This is called N dash is greater than N when source is moving towards the observer. So actually this you have to understand very carefully. When source is moving away, frequency decreases. When source moves towards observer, frequency increases. But in textbook is done different way using binomial expansion and all that. Not necessary. After finding T dash, you reverse it. 1 by N dash, you will get it. That is enough. So I told Doppler effect an important question. Sometimes they are asking Doppler effect 30%, 40%. They are asking open pipes or closed pipes. And sometimes they are asking strings also. Formation of, here we can't expect which question will come in waves. Generally either Doppler effect or open pipes or closed pipes they are asking. So now I am going to next long question. Next long question, current elasticity we are doing. Next we are doing current electricity. I am doing one of the important question, current electricity long question. What is current electricity long question? Current electricity long question I am doing. State Kirchhoff's laws for electric network. State Kirchhoff's laws for electric network. For electric network. You attempt please current electricity, this is scoreable. Waves also okay. State Kirchhoff's laws of electrical network. Using these laws, deduce the condition for Wheatstone's bridge. Using these laws, deduce the condition for balance of Wheatstone's bridge. Balance of Wheatstone's bridge is most important question. Let us expect 70% they are asking this, potentiometer 30%. So the 60% to 65% they are asking Kirchhoff's laws, electrical network, deduce the condition for balancing. That's why I am doing this one. Nuclear physics I will do nuclear reactor only. Time permits, radioactive disintegration also I will do 10 minutes. There are two questions. So first you will complete this Kirchhoff's laws and electrical network. This is interesting for you. What is this? So this is the question. Answer. What is Kirchhoff's first law? This is used for complicated network. Single loop circuits are there. Ohm's law is enough. What is Ohm's law? V is equal to IR. V is potential difference. I is current. R is resistance. I is V by R. V is equal to IR. That is valid for conductors at constant temperature. Kirchhoff's laws is an extension of Ohm's law. Kirchhoff's laws are extension for Ohm's law. Kirchhoff's first law. Kirchhoff's laws. First law. What is first law? All the sum of the currents entering the junction. Sum of the currents entering the junction is equal to sum of the currents leaving the junction. Sum of the currents leaving the junction. Sum of the currents entering the junction. Sum of the currents leaving at a junction. Some currents are coming. Some currents are at the junction. Some currents are coming. Some currents are leaving. For example, I1, I2, I3 are coming. I4, I5 are leaving. Therefore, I1 plus I2 plus I3 currents is nothing but I4 plus I5. Our algebraic sum of the currents is 0. I1 plus I2 plus I3 minus I4 minus I5 is 0. This is called Kirchhoff's first law. It is according to law of conservation of charge. According to law of conservation of charge. You write clearly, student, currents mainly. You can take one current, switch in two currents also. I is equal to I1 plus I2 also you can write. You take, compulsory is not compulsory. You can draw like this also. This is I, this is I1, this is I2. What is this implies? I is equal to I1 plus I2. I is equal to I1 plus, this is also Kirchhoff's law, simple circuit. The complicated network will have like this. What is Kirchhoff's second law? What is Kirchhoff's second law? I am writing. Kirchhoff's second law. What is Kirchhoff's second law? Algebraic sum of the potential drops. Algebraic sum of the potential drops around a closed circuit. Around a closed circuit. Closed circuit is 0. This is according to law of conservation of energy. So I am explaining second law in next page. So you have to follow some rules. So explanation you can do by using Wheatstone's bridge. Again, separate circuit is not necessary. First you write statement for Kirchhoff's first law, second law. Second law, you take a circuit, simple circuit. In that circuit, you can apply. So you can apply the law. For cells, how you take? For example, cell you are taking. Plus and minus. 2A, B is there. Okay, VA is the negative potential. Okay. It is EMF E. EMF E, negative to positive. VA plus E is nothing but VB here. VA plus E, minus to plus, current is going like this. So E is nothing but VB minus VA. That means E is a higher potential. This is a higher potential, this is a lower potential. For resistors in the direction of current, potential drop is nothing but minus IR. Same resistor, for example, current direction is this, upward direction, current is like this. So upward direction of current. So upward direction of, this is the current direction, let us say, by cell. Let us cell is there here, the direction of current. For example, cell is here, it is connected like this. So current is going like this way. So potential drop is nothing but equal to plus IR. Upward direction of current plus IR, in the direction of current minus drop, potential drop is minus IR. For cells, minus to plus, plus E. Same thing, VA minus VB, if you take, it will become minus A, minus E. VA minus VB is minus E. VB minus VA is plus E. Like this. This is the rules you will apply for closed circuit. Now I will do Wheatstone's bridge. Now I am doing Wheatstone's bridge. I am doing Wheatstone's bridge is an example for complicated network. It is a complicated network. It is a complicated network. You have to analyze with using Kirchhoff's laws. It is a complicated network. What is the complication? I am drawing. Friends, quadrilateral like that, you plan first, you plan the diagram. Plan the diagram. You keep opposite points here like this. You connect one resistance, another resistance like this, like this, another resistance like this. P, Q, RS or R1, R2, R3. Here between these two, battery is connected. Here galvanometer is connected. This is A, B, C, D. This is a complicated network because P and Q are not in series because this point is coming, galvanometer is coming. R and S are not in series because D point is coming. This is a battery supplying current high here. Current is splitting as I1, the current is splitting as I2 here. The current going to galvanometer is IG here. According to Kirchhoff's law, first law here, how much current will go? I1 minus IG will go here. What current will flow to SCS is I2 plus IG current here. According to Kirchhoff's first law. These are the current distribution. This is the current distribution. You describe the circuit. This is very important. PQ, RS are resistances connected as the arms of quadrilateral. As the arms of 20 minutes. 25 minutes. Are the arms of quadrilateral. Arms of quadrilateral. Between A and B, battery is connected. Between A and B, battery is connected. Between A and B, battery is connected. Between C and D, a galvanometer is connected. A galvanometer G, galvanometer G resistance is connected. Galvanometer G is connected. Circuit. Galvanometer G is connected. If you want circuit, I will give once again to you. So please see. It's connected. Please don't see my writing, students, today. PQRS are resistances. I am reading out PQR resistance. Please adjust my writing. Please don't criticize my writing. PQRS are resistance connected. I am sorry, absolutely sorry to complete syllabus. And that's why I am not taking all the questions. I might have been still in a hurry. But very, very important questions. Kirchhoff's law, I explain. Somewhere I have doubts. PQRS are resistances connected in the arms of quadrilateral. Between A and B, battery is connected. Between C and D. Okay, current distribution is done. Current distribution is done like this. Current distribution is done. Okay. Now, in the unbalanced bridge, In unbalanced bridge, Ig is the galvanometer current. Ig is the galvanometer current. Ig is the galvanometer current. How to apply Kirchhoff's laws here? I am showing you how to apply Kirchhoff's laws. I am telling you how to apply Kirchhoff's laws. Okay, students? So circuit, please see to it how to apply Kirchhoff's laws. I am telling there is a loop here, AC/DC. ACDA loop. You take ACDA loop. In ACDA loop, how will I do? Here only I will do ACDA loop. ACDA loop in the direction of current minus I1P minus Ig into G plus I2 into R is equal to 0. ACDA loop in the direction of current minus IR minus I1P minus Ig into G is I2R 0. In CBDC loop, okay, CBDC loop, what you will write? CBDC loop, CD. CBDC loop, please see current minus in CBDC loop. In CBDC loop, in CBD, once again I am drawing the loop. In CBD, I am drawing once again the loop. Students, showing you the loop. Here P, here Q, here R, here S. Here battery is connected. Here galvanometer is connected. G. Okay, students, here P is connected. Here Q is connected. C. This is C. This is D. This is C. Assume. Now C. Now I am telling you this is B. This is A. In CBDC loop, in CBDC loop, once again I am drawing. That figure may be there with you. This is battery sending current. Here I1 current is there. Here Ig current is there. Here I1 minus Ig current is there by Kirchhoff's law. Here I2 plus Ig current is there. I am writing minus I1 minus Ig into Q plus I2 plus Ig into S minus plus Ig into G is equal to, against the direction of current. Current is coming from C to D. We are going from D to C. CB in the direction of current minus. Opposite direction of current plus. opposite direction of current plus. So in the balanced bridge, you are right, in the balanced bridge, what is balanced bridge? In the balanced bridge, Ig should be equal to 0. Galvanometer current should be equal to 0. You are adjust the resistances such that we get balanced resistance. Here what will happen? This is second equation. We have first equation also. In first equation, what will happen? First equation you have. What is the first equation? Minus I1P, IE 0, okay, plus I2 into R is equal to 0. This says that I1P is equal to I2R. This is third equation. From second equation, Ig is 0, you are going to get minus I1Q plus I2S is equal to 0. Therefore, I1Q is equal to I2S. I am going to get fourth equation. You divide I1P by I1Q, nothing but I2R by I4S. I1 gets cancelled, I2 gets cancelled. You are going to get P by Q is equal to R by S. If you see complete notes in your whatever I am doing in the board, digital board, it is moving this way, that way. But after explanation, if you see, it will be very clear. P by Q is R by S is unknown. If you want, what will happen? S, if S is unknown, you will get QR by P. S. How to find S? To find S, S is nothing but QR by P. Q into R equal S into P. So S equal QR by P. Like this, unknown resistance can be calculated by using Wheatstone's bridge, student. Last question I am doing. Now I am doing nuclei. Lastly, I am doing nuclei. One more question is there in characteristic, but nuclei. Nuclei, most important question I am doing. Last question. Nuclei. We are doing nuclei. Potentiometer. Friends, potentiometer, comparison of EMF of cells. Principle of potentiometer, comparison of EMF of cells, or determination and resistance of cell. I am unable to do that one, but I am explaining nuclei now. Nuclei. Explain the principle and working of nuclear reactor. Explain the principle and working of nuclear reactor because this is asked a number of times than radioactivity. I am doing this first. Explain the principle and working of nuclear reactor with a label diagram. 60 to 70% they are asking this question in nuclear physics. Explain the principle and working of nuclear reactor. What is the principle? Nuclear reactor. Principle first I am writing. Principle is nuclear reactor works on controlled chain reaction. Controlled chain reaction is the principle of nuclear reactor. What are the main parts of the, I will draw diagram also. What are the main parts? Of reactor? Main parts of reactor. Controlled chain reaction, you write here, it is, they won't measure the length and give marks, student. They will give points. Controlled chain reaction, if you write 1 mark will be there. Parts, if you write 1 mark will be there. What are the parts here? Fuel means gas in house will do cooking, gas. Here uranium nucleus or plutonium nucleus you are using, fuel. Then moderator, there is a part called moderator. Second part. Third part is called control rods. Control the chain reaction. Protective shielding. So one is called coolants. Fourth one is called coolants. Fifth one is called protective shielding. Why protective shielding is there? To protect the human life. Protective shielding is there. Baba Atomic Research Center is there in Bombay. So nuclear reactor, fuel, moderator, control rods, coolants, protective shielding. This is the parts. I am drawing diagram now in the next page. I explain each part by part. Diagram. What is the diagram? Diagram, simple diagram you can draw. There are two types of diagrams are there. Textbook diagram is simple. We are using the diagram. Here core. Core means in that fuel is there. This is core, fuel is there. This what is there? Core. In this fuel is there. Core. Here is the box. Here control rods are there. Oh, here control rods are there. Core contains moderator also, control rods. These are called control rods. Control rods. This is fuel. Here I bring down the diagram. Diagram is very important. I'll show you the diagram. Diagram. Okay, student, this is diagram. Here coolant's connection is there. Here steam exchanger coil will be there. Coil is there to steam here. Water inlet here. Water inlet will be there. Here steam comes out here. Water inlet, steam comes out here. Here coolant. Coolant you are supplying. Inlet and outlet. Inlet and outlet. Coolant. Coolant. You remove this. Coolant. This is diagram. So this core, fuel, this is called control rods. Core contains moderator also. Core contains moderator also. The coolants, this is coil, this is coil. So water condenser is there, steam will come out. This is the diagram of nuclear reactor. Now I'm explaining the part by part and working. What is fuel? Fuel is nothing but fuel is sealed in aluminum cylinder. Fuel, nuclear fuel. Nuclear fuel is sealed in aluminum cylinders. Aluminum cylinders. Fuel is sealed in aluminum cylinder like uranium 235. Like uranium 235 fuel. The first part is fuel. Second part moderator. Moderator is used to decrease the velocity of neutron. It is used to decrease the velocity of neutron purpose. Decrease the velocity of neutron. I am explaining only this, how velocity is decreased and all that by colliding can decrease. What is used in moderators? Examples for moderators are heavy water D2O and graphite. They are used often moderator. Then control rods. Control rods. What is control rods? Cadmium rods are used. Cadmium rods are inserted such that in and out, such that chain reaction is controlled. Such that chain reaction is controlled by absorbing neutrons, by absorbing fast neutrons, by absorbing even slow neutrons. Neutrons should be slowed down. That is called thermal neutrons. That is useful for nuclear reactor. That is useful for heat energy to get, because whenever fission takes place, whenever nucleus is breaking, heat energy will come. When nuclear is breaking, heat energy will come out. Exothermic reaction, you know that. Control reacts. Then protective shielding. Then fourth one is called what? Sorry, coolants. So important is coolants. So there is supply of coolants The rods coolants, what coolants will do? Coolants remove the heat generated, in the reactor, heat generated in the reactor. I'll write in next page. Heat generated in reactor. Coolants are heat generated in reactor. To remove heat generated in reactor, to convert into steam. What is coolants used? Coolants are water, molten sodium. They are using molten sodium. Coolants used are, what are coolants used? Coolants used are, this is coolants. So I am writing here once again. Don't write in the examination like this, students. You completely strike the sentence and write. Don't overwrite anywhere. As a student, write very much neatly in the sense, and presentation means that not this one, writing. Somebody's writing may not be good, something like me, but writing they won't see much. How you are presenting, how you are writing definition, how you are explaining moderator, how you are explaining control rods, correctly writing or not, that is called presentation. So all points you are writing or not. Coolants. Lastly, protective shielding. Lastly, I am writing protective shielding. So reactor is surrounded by lead walls. Reactor is surrounded by lead walls. Surrounds are lead walls to absorb dangerous radiations. Dangerous radiations like krypton and all that. Protective shielding. This is what that. So what is working? All this together you are write as working, student. Working, I am reading out, student, for you. What is the working? You are write the parts. Diagram 1 mark, parts 1 mark. Explanation of parts 4 marks. Explanation of parts 4 marks. Principle 1 mark, diagram 1 mark, 4, 1, 5, 6. Working 2 marks. What is working? Same together. So uranium fuel rods are arranged in aluminum cylinders. Graphite moderator is used to decrease the velocity of neutron, activate fission. Cadmium rods are used to absorb the excess neutrons, and heat is removed from the reactor. So what will happen in working? What will happen? Steam generates, steam rotates, steam rotates turbines, and this mechanical energy converted to heat energy, converted to electrical energy. This is for peaceful purpose, but this is not enough working. But you are tried like this. Fuel is sealed in aluminum cylinders. Moderators are used to decrease the velocity of neutron. With the help of control rods, will absorb the excess neutron to control chain reaction, putting in and out. You can halt the chain reaction at any place. Heat should be generated, but should not be very, very high. If very, very high, what will happen? It will go to atom bomb. Uncontrolled chain reaction leads to atom bomb. So it should be controlled, useful for peaceful purposes. That is the nuclear reactor working. They are asking problem also. Micrograms of uranium surface destroyed atom bomb. How much energy is released? E is mc square equation you have to use. So finally, radioactivity is there. Final question in nuclear physics. Sometimes they are asking radioactivity. I'll just see to it how can I explain that or not. I am not following any book, student. Don't worry about my book. This book, I brought the book only for which questions are important. To see only, I am having some kind of fulcrum. What questions are, because from textbook, we are being and explain, this is last moment. I have not explained all the questions. Nuclear physics, one more question is there, radioactivity. Radioactivity. Okay, students. So I'm stopping here, students. My dear students, all the best for your examination, intermediate second year physics, whenever it comes. I think it comes in between 13 to 17. March 13 to 17 physics examinations are there. After 12th or 13th, we are having physics examination. Physics exam 2 days rest is there. So we are ending the long questions here. Nuclear physics, one more question you practice, that is what is radioactivity and what is the radioactive disintegration law derivation. So nuclear physics, one question I did, waves, 2 questions I did, electricity, 1 question I did. 2 plus 1, 3 plus 3, 4. 4 questions I did, important questions. Okay, students. So all the best, all of the students here, go through clearly. Digital board, even though you'll get, but you will get nicely only. Up and down for me it comes, but for you get all the best, students. I'm Srinivasan, Physics from Spark Academy. I completed second year portion for you.